Okay, this is the Professor, CBMD PhD, and today's Tuesday, October 17th, 2023. It is 8:56 and 40 seconds, p.m. Eastern Standard Time, and today's research, photonic crystals. So let's come to it here. The photonic crystals bend light as though it were under the influence of gravity. Date October 16th, 2023. Source: Tohoku University. The scientists have theoretically predicted that light can be bent under pseudogravity. A recent study by researchers using photonic crystals has demonstrated this phenomenon. This breakthrough has significant implications for optics, materials, science, and the development of 6G communications. Albert Einstein's theory of relativity has long established that the trajectory of electromagnetic waves, including light and terahertz electromagnetic waves, can be deflected by gravitational fields. The scientists have recently theoretically predicted that replicating the effects of gravity, important example, pseudogravity, is possible by deforming crystals in a lower normalized energy or frequency region. They set out to explore whether lattice distortion in photonic crystals can reproduce pseudogravity effects. The photonic crystals possesses unique properties that enable scientists to manipulate and control the behavior of light, serving as traffic controllers for light within crystals. They are constructed by periodically arranging two or more different materials with varying abilities to interact with and slow down light in a regular, repeating pattern. Furthermore, pseudogravity effects due to adiabatic changes have been observed in photonic crystals. The scientific investigators have researchers modified photonic crystals by introducing lattice distortion, gradual deformation of the regular spacing of elements, which disrupted the grid-like patterns of photonic crystals. This manipulated the photonic band structure of the crystals, resulting in a curved beam trajectory, a medium just like a light ray passing by a massive celestial body, such as a black hole. And specifically, they employed a silicon distortion photonic crystal with a primal lattice constant at 200 micrometers and terahertz waves. Experiments successfully demonstrated the deflection of these waves. Much like gravity bends the trajectory of objects, they came up with a means to bend light within certain materials, such as plane beam steering within the terahertz range, to be harnessed in 6G communication. Academically, the findings show that photonic crystals can harness gravitational effects, opening new pathways within the field of graviton physics. And this is a professor of space technology, advanced physics, mathematics, computer science, and leader of research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.